Hello everyone. In this video, we'll discuss about the concept of inheritance in object-oriented programming. Inheritance is one of the key features in the context of OOP or object-oriented programming. This allows us one class to have the properties of other class without replicating the same block of codes that does the similar function. While talking about inheritance, we need to be mindful about two main components of it. One component is base class, or the class whose properties are inherited from, and the other one is the derived class, the class which inherits the properties. Whenever we need to implement inheritance, we follow the format below to create the derived class. So here we start with the keyword class, then we provide the name of the class or the derived class name, which is dr underscore cls in this case. Then we use a colon, then we say the keyword public, then we use the name of the base class, which is base underscore cls in our case, and then we start writing the body of the derived class. One major application of inheritance is the use of less lines of code to package your classes nicely. Inheritance also opens the door for implementing polymorphism. In polymorphism, a member function of the base class can be implemented differently in the derived class. In other words, polymorphism allows to morph one method of the base class into a different form in the derived class. Next, we will see how to implement a derived class from the base class using inheritance. Okay, now we'll see a coding example where we will implement class inheritance, where we'll have a base class and we'll use the functions and features of the base class to be used by another derived class. And this entire procedure, as we have already identified, is known as class inheritance. So for that, we'll go back to our previous class implementation where we had already implemented the class cplxnum, and we had this different type of constructors in this class that we had implemented, and also we had this member methods get real, get imaginary, and cplx print, all these, and then we have couple of operator overloadings, like we have overloaded the plus operator, and we also had overloaded the left shift operator for using cout to print the object of type cplxnum. But before we start creating the class of that will inherit its property from the cplxnum, let's do some changes here in the type of the real and imaginary. In general, these real and imaginary numbers will be a float type, so let me make these floats, and same for the constructor. So the constructor will now take in float type variables for the real and imaginary numbers. Again, for the get real, it will be a float, and get imaginary will also be a float type number. And once we do that, we'll just go back to our CPP file where we again just need to change these integers as floats. we'll just do it quickly so that we can concentrate on writing the derived class. That's the main concentration of this video. Okay, looks good. And now we'll get back to our header file where we'll start creating the derived class, and the name of the derived class is suppose cplx num ph, because this will be the derived class from the cplx num. However, this will also contain the phase angle of a complex number, and that's the new modification that we are going to implement in the derived class, which was not there before in the base class. And in this case, the derived class is cplx num ph and the base class is cplx num. And as we have already mentioned, we need to now use the public keyword. After that, the name of the base class, which is cplx num, and then we'll create a private variable which is again a float type, and it will be the phase angle. Then under the public column we'll have, so this is again the access specifier under the public. We'll create the constructor for this class. So the constructor will have the same name as the derived class name, and it will be very similar to the one that we have seen for the base class. However, we'll see that the constructor does little bit of more work in this case for the derived class as compared to the base class. We'll implement that constructor in the CPP file later, but let me first show you what are the different functions that we probably want. And then we want to implement get phase method. We also want to implement the destructor for this particular class, and again destructor will have the same name of the class name, but before that we have a tilde sign here that identifies, and that will be identified as the destructor. Okay, so this is our more or less the code that we wanted to incorporate inside the header file. Now we'll go back to the CPP file where we'll be implementing the class constructor for the derived class that we are creating now. So it will be very similar to the one that we have seen before. However, as I said, it will perform little bit of more work. Inside the constructor, we assign real as r, img as I, and ph as 8 and I divided by r. Okay, so that completes our implementation of the constructor. The next function that we want to create for the derived class is the cplx num ph, and then we want to suppose retrieve the phase angle, which is supposed to get phase, and this function takes no input argument, just returns the variable ph. Next that we want is to implement is the destructor, which is implemented as this destructor will do nothing but print for this case that cplx num phs destructor is called. That should be it. And yeah, next we'll come back to our CPP main function. The name of this file is class underscore inheritance, which contains the main function, and this also includes the header file that we are modifying so far. Now inside the main function we will first create an object of the derived class, and suppose so the type of the object that we want to create is cplx num ph, and the name of that object is suppose cph num1, and then we'll provide the real and imaginary values. Okay. Now if you remember that when we had created the derived class, we never implemented the get image or get img or get real methods, because this is a derived class. So as per the rule of inheritance, we should have access to this get real and get img methods of the base class. So let's see if that's true or not. So what we do here, we will call the get img and get real and get img methods for with the object that we just created, cph num1, and if we have our implementation right, we should have access to these functions. Now we'll compile our code and see if everything working fine or not. We have some error in the header file, line number 25. There is a typo. And then the another error, no float cplx ph get phase. Okay, so let's recompile the code and see whether we have any error. Okay, so all the errors are now corrected and we have our output file. Let's run the output file. The name of the output file is class underscore inheritance. And yes, so it didn't print anything because we just called, we did not print the real and imaginary, but everything worked fine. Just to visualize what we get, as when we call the get real and get img, we are printing them. Same here. Print the get real and get img. Okay, so let's recompile and run the code. And we have another error. We missed the left shift operator for printing. We need to save this and then we'll recompile our code. We have 2ss, we'll recompile and it compiles. Now print the output. and it prints 4 as a real number but 0 as the imaginary number. We do not know what happened. Go back here. So yeah, it's there is a minus sign. It's supposed to be img is equal to I. Okay, let's now recompile the code and see what we get. It compiles, here is the output, and we get the right variable out as output, right number as output for the function called getReal, and the output of the function getImg is 5. So looks good. And then another thing to notice here is that the destructor for the complex num ph is called first, and then the destructor of the base class was called when we have a derived class. Makes sense. Now we'll see that can we have the phase angle, which is specific to the derived class, which was not there in the base class. So we'll see that here again. So we'll call get ph, and then here we'll compile the code. It says cplx. Okay, so there is no function name like this. It's get phase. The function name is get phase. Okay, so it should compile now. Yes, it does. And we'll just need to run the output file. Okay, so we get the right phase angle here. So I think that's all for this video. So in summary, we had our base class, and then we used that base class to implement a derived class here. And the main point for this example was that we did not implement the getImg and getReal methods for the derived class, and we still had access to those methods since the base class had those implemented. However, this derived class has further extended functionalities beyond the base class, which is the phase angle, and it has therefore a new member variable called ph, and it has another member method which is getPhase, and it also had a separate destructor. So these are the functionalities that I wanted to show for creating a base and derived class from a base class using inheritance. I hope this is helpful. If you like this video, please give it a thumbs up and subscribe the channel. Thank you for watching.